Hi, this is the introduction to lab exercise number 2. This exercise is the workshop that goes with the deep learning design patterns primer part 2. So we have this bit.ly link here. I'll give you a moment to copy it onto your laptop. So we're going to go ahead and click on it or open it. And this is going to take us to a Jupyter notebook that's hosted in my Google Cloud AI Developer Relations GitHub repo. So I click on it. Here we are in my repo. And GitHub actually supports Jupyter Notebook. So you can see it actually launched the notebook. But we're not going to run it from here because it would run on your laptop. Instead, we want to run these workshops on Google Colab. The advantage is you don't have to worry about having all the right software installed. Everything we need is pre-installed. So to do that, we have this initial cell here, running Colab. I want you to click on it. And this will relaunch the notebook inside Google Colab. So a couple more steps I want you to do. First, by default, Colab uses a CPU. It's really underpowered. Now, for the purpose of this exercise, you really don't need additional power, but as you go on to more and more exercises, you will need the power. So it's just good practice right now to change the runtime type to include a GPU. So we're going to go up here to runtime, click on it. Then we're going to go to change runtime type. And we want to look at hardware accelerator. We don't have one right now. We're just the CPU. So we're going to go ahead and add in the GPU. Okay, now your notebooks are going to run a lot faster. Also, the first time you run, there's this security pop-up that shows up. It says do this. This is just noting that this notebook wasn't done by Google. It's making sure that you're aware that if you got this notebook from somebody else, there may be some security or privacy issue. We made the notebook, so I assume you can trust us. So let's go ahead and do run anyways. Okay, so that gets us past that. Now, the way this works is there's a set of steps here. And in each case, we're going to have you make a fairly basic convolutional neural network. Now, actually, all the code is already there. What we've done instead is we've taken the code to build a specific convolutional neural network and intentionally left parts out, wherever the double question marks are. And your job is to figure out what to put in there. And we do a few things to help you out. First, we explain to you what you're going to need to do. So in this first example, you're going to do a basic convolutional neural network using the sequential API. So you're going to set the number of channels on the input vector. You're going to set the number of filters and stride on the convolution layers, and you're going to set the max pooling window size and stride. So I'll go through this very first one so you get familiar. So here we are, the input shape. We need to set the number of channels. Well, wherever I have these question marks, we also try to give you a big hint. So in this case, how many channels are in an RGB image? R, that's 1, G, 2, B, 3. Maybe that's the answer. Let's go on to the next one. So we have this convolutional layer here, and we need to set these two parameters. What are these two? What are the first two positional parameters on conv2d? So our hint here is the first parameter is the number of filters, and the second one is the filter size. So let's say we're going to do 16 filters. And we're doing a filter size of 3 by 3. Maybe that's a tuple of 3, 3. Oh, here we are in the max pooling. And again, the hint is a 2 by 2 window with a moving 2 pixels at a time. So what is the first positional argument here? I think it's the window size, be a tuple, 2, 2. When we're moving the window, that is the stride. So I wonder what this value is going to be. So that's basically how it works. And you fill this in, and you know it's correct by two things. One, you don't get any compile errors. It compiles. And then there'll be a step afterwards where you'll execute a summary on the model, and we show you ahead of time what the output should look like. So the output from what you did should match this. Wish you all the best of luck. These are actually fairly easy to do. On average, people finish these workshops in 10 to 15 minutes.